Hey good people, welcome back. In this video, we're going to learn how to solve quadratic equations. We're going to look at two methods today. The first method we're going to look at is called solving by factoring, and the other method is solving by completing the square, which we learned that process last week. Let's take a look at our first example. This one could be solved by either of the two methods, but it's probably easier just to use factoring here. And that's because we can think about this. We can find numbers that multiply to -40 and add up to -6. And to factor that -40, you really just want to take -40 or 40 and divide it by numbers starting at 1 to build all your factor pairs. And I'm just factoring -40 by dividing it. It's not divisible by 3. That gives us a decimal. All right, -40 divided by 4. I'm going to start writing out some of these factor pairs. So it was 1 goes into it 40 times, 2 goes into it 20 times, 4 goes into it 10 times, and I think that was the one we were looking for. -10 plus +4 is what's going to add up to -6. So we found our pair of numbers that multiply to -40 and add up to -6. They are -10 and +4. So I'm going to use that to factor this quadratic trinomial as a product of two binomials. So here we just put an x because x times x is what gives us this x squared. And then here we're just going to put in our factor pair, +4 and -10. If you were to FOIL this out, you could find that that multiplies to -40, and the outer times the outer and the inner times the inner give you -10x, +4x, and they add up to -6x. So this is factored correctly. All right, well, we're actually solving an equation here, and we have a little statement that says the quantity x plus 4 multiplied by the quantity x minus 10 is equal to 0. Well, what do we remember about multiplying and getting 0 as the answer? If two factors multiply to equal 0, then we know one or more of those factors must be equal to 0. That's the only way you get 0 as the answer to a multiplication problem. And in algebra, this is called the zero product property. The zero product property is what enables us to solve these quadratics by factoring. The zero product property states that if you have two numbers a times b and their product is equal to 0, then we know either a is equal to 0 or b is equal to 0, or perhaps both. So we have that going on over here. We have something times something equals 0. So what we do is to consider the possibility that x plus 4 is what's equal to 0. You go off to the side and you set up that equation, x plus 4 equals 0. To consider the possibility that x minus 10 is what is equal to 0, you go over to the side and you consider that possibility by equating that to 0. Now we solve each one of these independently, and we have our two answers. X is equal to -4, and x is equal to +10. That's actually, they're both answers to this quadratic equation, and they both work. Just to prove that, we had x squared, so I'm going to do -4 squared minus 6x minus 40, and I hit enter. I should get what's on the right side of that equation, which is 0, and it is. And I'm just going to check my other answer. My other answer was +10. And that's also going to solve this equation. So in general, quadratics can have up to 2 real answers. And just to generalize that even further, there's something called the fundamental theorem of algebra that says the degree of your polynomial equation tells you the number of real roots that it may have. So since this is a degree 2 polynomial equation, it can have up to 2 real answers. And that sort of has to do with the shape of the graph. If you look at the graph of this function, x squared minus 6x minus 40, it has this parabolic shape. And you can see that it actually crosses the x-axis at -4 and +10 are two answers. The other situation that can arise when you're solving quadratics is that the parabola maybe doesn't hit at 2 times. Maybe it only just touches the x-axis and there's one answer. Or perhaps it never crosses the x-axis at all and then there's no real answers. Let's look at another example. X squared plus 4x minus 5. We're going to use factoring again here because we can find a pair of numbers that have a product of -5 and a sum of +4. So think about numbers that multiply to -5 and add up to +4. -5 is divisible by 1. That's actually really the only thing that goes evenly into -5. Do these add up to 4? No, they add up to -4. So let's try switching the signs. How about -1 and +5? All right. Those add up to +4, so that is the factor pair we're looking for. -1 and +5. They multiply to -5 and add up to +4. So we're going to factor this as x minus 1 and x plus 5. All right, and you can verify that by foiling it, but that's correctly factored. Now we have a statement that says this binomial multiplied by this binomial is equal to 0. So we know either one or perhaps both of them equal 0. So we go off to the side and consider each one of those possibilities separately by equating each binomial to 0. And now we solve. We get x is equal to 1 and x is equal to -5. So our two answers are 1 and -5. So when you're listing your answers, you can write the word "and" in between your two answers, or you can just say x equals -5, comma 1. You can list your answers like that. All right, this is another example where we can use factoring to solve. We have to find two numbers that have a product equal to -14 and a sum equal to +5. I usually just start at my number that I'm looking for things to multiply to, and I just divide it by 1 all the way up to the square root of the number. And 1 goes into -14 times. How many times does 2 go into -14? -7 times. And we didn't find the pair that multiplies to -14 and adds up to 5 just yet. And we only have to check up to the square root of 14, which is 3 point something. All right, so we figured out every factor pair. So since these don't add up to +5, I'm just going to try switching the signs. Because they have to multiply to a negative and add up to a positive. All right, and then we found it. This is the pair of numbers that multiplies to -14 and adds up to +5. So I'm going to factor my quadratic. X times x is x squared. And now I'm going to put in my -2 and my +7. That multiplies to -7 and adds up to +5. So since these two binomials multiplied to equal 0, we know that one or more of them must be equal to 0. So I'm going to equate each of them to 0. And solve independently. Add 2. So we have x is equal to 2, and x is also equal to -7. So our two answers are 2 and -7. X is equal to -7 and 2. All right, let's do another example. This next example is a little bit more challenging because of all the decimals involved. You can't really solve this by factoring because it's a hard number to work with, -12.1875. To figure out all the factor pairs that multiply that is very unrealistic. But we're going to use the technique that we learned last week called completing the square, but this time we're actually using it to solve an equation. So if you remember from last week, completing this square involves taking half of the x coefficient and then squaring that and adding it and subtracting it. Instead of adding it and subtracting it, we're going to add it on both sides of the equal sign, which is the same exact result. It's still a net change of 0. You don't really change anything in the equation. So I'm going to take half of 0.5, square that, and I'm going to add it and subtract it, or add it on both sides of the equal sign. 0.0625. Added it here, and I added it here. 0.0625. All right, so we just constructed what's called a perfect square trinomial. This x squared plus 0.5x plus 0.0625 is a perfect square trinomial, and that can be factored as x plus the square root of 0.0625, which is 0.25, x plus 0.25 squared. So we have the quantity x plus 0.25 squared minus 12.1875 is equal to 0.0625. And then we're just going to move that minus 12.1875 onto the other side by adding it on both sides. So we have to do 0.0625 plus 12.1875. And that's 12.25. So we have the quantity x plus 0.25 squared is equal to 12.25. Now, to solve this, x is being added by 0.25, then it's being squared. We're going to unsquare it by taking the square root. So we just need to take the square root of both sides of this equation. And we haven't done this yet, but it turns out that there's actually two square roots to a number. The positive principal square root and the negative square root. So we have to consider both of the positive and the negative square roots of 12.25. And that's simply because the calculator will give you the positive answer, but if you also multiplied negative 3.5 by itself, a negative times a negative is a positive. So that would also give you 12.25 as the answer. So there's two answers to this, 3.5 and negative 3.5. So we're going to write both of those answers down. We have to consider them. They're both equally valid. Let me get some more space to write here. So we are, the square root gets rid of the squared of that x plus 0.25 squared. So that's no longer squared. The square root got rid of that. The answer to the square root of 12.25 is equal to 3.5, but it's also equal to negative 3.5. And we have to consider each of them independently, the positive square root and the negative square root. Now we solve each one of these equations, and then we'll have our answer. 3.5 take away 0.25. We get 3.25. And we have negative 3.5 take away 0.25. And that's negative 3.75. So this question had two answers like the other three that we did. And the answers are positive 3.5 and negative 3.75. And we solve them by using completing the square. Let's do another completing the square. All right, so this one again has decimals in it. We're going to begin by halving the x coefficient, take half of that, and then square it and add it on both sides of the equal sign. So you have x squared minus 1.5x. Half of 1.5 is, well, half of negative 1.5 is negative 0.75. And we have to square that, which is 0.5625. So I'm going to add 0.5625 to both sides of the equal sign. And now we've created what's called a perfect square trinomial. Those first three are perfect square trinomial. And that can be factored by doing the square root of the first term. Square root of x squared is x. The square root of that third term, 0.5625, which is 0.75. And separating it with whatever sign is in the middle there. There's a minus in the middle. Squared. All right, now let's move this minus 27 onto the other side by adding it on both sides. So 27 plus 0.5625 is 27.5625. So we have the quantity x minus 0.75 squared is equal to 27.5625. To solve this, we got to get rid of the squared, and we're going to do that by taking the square root. So we got to take the square root of each side. And when we do take the square root, we have to remember to take both the positive and the negative square root. All right, so the square root of 27.5625 is 5.25. So we have to get rid of our square root over here. X minus 0.75 squared, the square root of that is just x minus 0.75. And that's equal to the square root of 27.5625, which is 5.25. And the other answer is the negative answer to the square root of 27.5625. It's negative 5.25. That is something the calculator will not tell you, that there's actually two square roots to numbers, and it's something that I guess you were never really told in middle school or maybe elementary school. They never told you that there's two square roots to every number, the positive and the negative, but you have to use that here. All right, let's finish this out. We got to add 0.75. $5.25 plus 0.75. Nice, that works out nicely. That equals 6. So x is equal to 6. And negative 5.25 plus 0.75. That is negative 4.50. 4.5. So x is equal to negative 4.5 and positive 6. Those are our two answers. Just to verify that these answers are correct, you could always check your work by plugging them into the original problem. Sometimes I like to do that just to check my work. When I hit enter, it should tell me it equals 0 because that's what the original equation was set equal to. Good. I'm going to check my other answer. I have to put a negative 4.5 in there. When I hit enter, it should also tell me equals 0. It should also work. And it does. So our answers are correct. All right, one final example. X squared minus 6.5x minus 3.5. So we're going to begin this, because it has decimals, by using completing the square. We have to take half of the x coefficient and then square that. So half of negative 6.5 is equal to negative 3.25. Squaring that gives us 10.5625. So you have x squared minus 6.5x and we have to add 10.5625 to both sides of the equal sign. This is the completing the square process. All right, we've constructed what's called a perfect square trinomial, and they're pretty easy to factor. You just take the square root of the leading term, the square root of x squared is x, the square root of that third term, which is negative or 3.25, and you separate it with whatever sign's in the middle there. There's a negative in front of the x, so that's going to be minus, and that's binomial is squared. All right, let's move the 3.5 to the other side of the equal sign by adding it on each side. So we have 10.5625 plus 3.5. That's 14.0625. All right, then we have to get rid of the squared by taking the square root of each side. Square root of the quantity x minus 3.25 squared is just the quantity x minus 3.25. And the square roots of 14.0625 are the positive answer and the negative answer. Let's see. 3.75 and negative 3.75. So x minus 3.25 is equal to 3.75, and x minus 3.25 is equal to negative 3.75. That's two answers. Gotta add 3.25 on both sides. So x is equal to 7, and x is equal to negative 1/2. All right, so two answers, 7 and negative 0.5. All right, thank you for watching the video. I hope this helps you learn how to solve some quadratics. The new assignment that I uploaded on Monday is due on Friday. It's just 6 problems, very similar to what you saw in the video here today. Hope to see you in our meeting scheduled for this afternoon, and thank you again for watching.